Hi everyone, today we're going to solve linear systems using the elimination method. Go ahead and grab a piece of paper and a pencil and let's get started. So the first thing we're going to look at are the steps to solve using the elimination method. Step 1, we're going to write both equations in the same form. Step 2, multiply the equations by non-zero numbers so that one of the variables will be eliminated if you take the sum or the difference of the equations. Step 3, take the sum or the difference of the equations to obtain a new equation in just one unknown. Step 4, we're going to solve for the remaining variable. Step 5, we're going to substitute the value from step 4 back into one of the original equations to solve for the other unknown. And last but not least, step 6, we're going to check the solution in each of the original equations. Okay, let's put those steps into practice and look at an example. So we're going to use the elimination method to solve x plus 2y equals 15, and then the second equation is 5x plus y equals 21. So notice that they are both in ax plus by equals c form. So they're stacked kind of one on top of the other. So actually this is going to make it much easier for us to use the elimination method. So what we need to do next is we need to either make the x's match, so either we're going to have 5x and 5x, or we can make the y's match and have 2y and 2y. So it doesn't really matter. I'm going to get the y's to match. So I'm going to again start by calling this equation 1, equation 2. And I'm going to multiply the second equation by 2. So 10x plus 2y equals 42. And then I don't have to do anything to the first equation, except I am going to move it over so that it's written right on top of my new equation. So x plus 2y equals 15. So now we have to think about what operation do we have to use to eliminate the two y's. If I subtract these two equations, my two y's will actually be removed or eliminated. So let's take a look. So x, or 1x, minus 10x would give me negative 9x. And then 2y minus 2y is just 0y, so I don't need to write that. And then 15 minus 42 is negative 27. So last but not least, we're going to divide each side by negative 9. So x is equal to 3. So we're halfway done. So now we use the same steps that we used for the substitution method. So we're going to take x equals 3 and we're going to sub it into either equation 1 or 2. So I think looking at the two equations, it would be easier to sub it into equation number 1. But again, you can choose either equation. Okay, when I sub x equals 3 into equation 1, I have 3 plus 2y equals 15. So I'm going to solve for y, so 2y equals 15 minus 3. So dividing both sides by 2, y is equal to 6. So therefore the solution is 3, 6. Sorry, I'm running out of space here. So therefore 3, 6 is the solution. Okay, let's go ahead and look at our next example. So again, we're going to use the elimination method, and we need to either get the x's or the y's to match. It doesn't matter. So the first thing I'm going to do though is label equation 1 and equation 2. Okay, so I'm going to eliminate the x's. So I'm going to multiply equation number 1 by 3 and multiply equation 2 by 5. So this will give me 15x and 15x, which will be able to be eliminated. So 15x minus 9y equals negative 3 is my new equation number 1, and 15x plus 10y equals 35. Okay, so to eliminate the 15x's, we're going to subtract the two equations. So 0x, so negative 9 minus negative 10 is negative 19y. So 15x minus 15x is 0x, negative 9 minus 10 is negative 19, and negative 3 minus 35 is negative 38. So just be careful with your signs there. So the last thing we're going to do is we're going to divide each term by negative 19. So y is equal to 2. So the next thing we're going to do is we're going to substitute y is equal to 2 into either equation 1 or 2. So let's go ahead and sub it into equation number 1. So 5x minus 3 times 2 equals negative 1. So 5x minus 6 equals negative 1. 5x equals negative 1 plus 6 is 5. So x equals 1. So I can conclude that the solution to the linear system is 1, 2. Okay, one last example. 2a plus b equals 14, 2a minus b equals 10. So let's go ahead and label our two equations. And it looks like it would be the easiest to get rid of the b's because they both have a 1 in front of it. So because our signs are opposite, we are going to add the two equations this time. And so I can go ahead and just do that right here. I don't have to do any rewriting or anything. So I could actually also get rid of the a's if I wanted, so it doesn't really matter. So if I add this, I have 4a, and then positive b plus negative b is 0b equals 24. So a equals 24 divided by 4. So a equals 6. Okay, so next we're going to sub a equals 6 into either equation 1 or 2. I'm going to substitute it into equation number 1 because my b is already positive. So 2a, oops, I guess I should write a. So 2 times 6 plus b equals, so 12 plus b equals 14. So b is equal to 14 minus 12. B is equal to 2. So therefore the solution is 6, 2. Okay, that's it for today. Thank you very much for your attention. Have a great day. Bye-bye.